Right, thank you very much, John, and welcome everyone. So this evening I'm going to talk about our experience building COVID-19 contact tracing applications. My name is Colm Harte, and I'm a technical director at NearForm. So just to very quickly tell you about NearForm. So NearForm is actually based out of the southeast of Ireland. We're a company of 150 people, founded back in 2011. And our workforce is spread across 21 countries, as we've been a remote first company since the start. We did a lot of work for enterprise customers, primarily in Europe and North America, and dealing with a lot of big names such as Condé Nast, IKEA, Ernst & Young, and others. So our journey in relation to COVID-19 started back in March, which is when COVID-19 was starting to gain traction all around the world and getting a lot more media attention. So everybody was starting to become a lot more familiar with the daily headline stats. In Ireland, you could see that the cases were starting to rise, deaths were also starting to increase. You had headline figures being reported every day, and everybody started becoming a lot more familiar with terms such as epidemiology, R numbers, etc. On the 12th of March, Ireland actually went into its first full lockdown, which was the most restrictive lockdown we've had since COVID-19. And that was basically all non-essential businesses were closed, schools closed, childcare facilities were all closed for a period of 3 weeks, and people were asked to restrict their movements to within 2 kilometers of their home. Because we're a remote first company, we also had the opportunity to talk to our Italian colleagues who've gone into lockdown earlier. So one of the things we did is we just set up a call with the Italian team in NearForm to find out how their experience was going during a lockdown. I suppose what we're trying to understand was the actual personal impact on people as opposed to a lot of the headline stories you heard through the media. So it's great just to hear that human side of things in terms of how a lockdown actually has an impact on your day-to-day life. And then one of the other relevant things to this story that happened on the 20th of March is that the first digital contact tracing application was launched. Now this was launched by Singapore. They launched that on the 20th of March, and it was on the 20th of March, and it was using Bluetooth to do proximity detection. As I said, they were the first to launch, and there was a lot of interest across the world in the Singapore app in terms of how it worked, if they would make it available to other countries, if they would make the source code available. And it was, I think at one stage they had 40 to 60 countries lined up looking to speak to them and get more information exactly how their app worked. So the NearForm journey actually started on the 22nd of March. We got a call from the Irish Health Authority, the HSC, to basically ask if we would be able to help them build a digital contact tracing solution. They were aware of the Singapore app that had been launched. They were hoping that Singapore were going to open source their code quite quickly. And then if they had, the plan would have been that they'd take that code base, effectively reskin it, and make it available then as the Irish app. But just in case that didn't happen, they wanted to kick off the effort to build their own in parallel. And they had some very simple high-level requirements. The main challenge that they presented us was effectively, how do you identify when people are too close for too long, right? And that was the real challenge around contact tracing with COVID-19. And in Ireland, the rules were that you needed to be 2 meters or closer for a duration of 15 minutes or more, and that would be considered a close contact event. Now, it sounds like a fairly simple problem, right? I mean, too close for too long. But the challenge was, how do you actually implement this? You're going to need hardware to do it. And we looked at what everybody has from a hardware perspective. Most people have smartphones, or certainly it's one of the most common pieces of hardware that's out there. And then you can look at a smartphone to see what kind of capabilities are within a smartphone that would allow you to do that proximity detection. So you have options such as GPS. You can look at Bluetooth. You can consider ultrasonics. There were some people attempted to go down the GPS route, and some apps have been launched that utilize GPS. But the big problem with GPS really comes down to the privacy concerns of users, because now it effectively means that your government is tracking you on a daily basis in terms of where you are, locations, etc. So clearly that's going to be very challenging to get actual user adoption with. Ultrasonics, again, can give you very accurate distance detection, but you have a challenge again from a privacy perspective, because for it to work, your microphone has to be on at all times. So again, thinking about it from a mass user adoption perspective, that's going to be a challenge, right? People are not going to be willing to have their microphone on 24/7. So that leaves Bluetooth on a phone. And that was the technology we decided to use, and it was technology that other countries were also looking into in terms of utilizing for this same problem. And the goal of the digital contact tracing solution was to augment the manual contact tracing. So that was already up and running. They had similar criteria where if somebody tested positive, they would contact them, they would ask them who they've been in contact with over the last few days. And again, they kind of asked them that same question, like who have you been close to, i.e. 2 meters or closer for approximately 15 minutes or more. Now, that's quite difficult to determine even in a manual scenario because most people, you're not measuring exactly how close you are to people. But it's effective for manual contact tracing because people will always be able to list out the people they're most frequently in contact with. And then some of the other features they wanted within the app was a symptom checker. So that people could record if they were starting to experience any of the symptoms of COVID-19. And they also wanted to be able to provide some information to users around COVID-19 in Ireland. And then the other key piece was they wanted privacy to be front and center. So we got that call on a Saturday. On the Sunday, we kicked off the design work. So 2 of our designers got together and they started building a prototype. And the goal was to have a prototype available by Monday morning for a dev team to start building. So I guess one of the benefits of being remote is we didn't have to worry about trying to get people physically together. We just used all our normal tools like Slack, Bureau, etc. So the team could start working immediately and collaboratively together. They first put together an overall wireframe of the journey. So this covers the key criteria that have been identified in terms of requirements and the various different screens and flows that we need to build these into an actual user application. And all of this is about getting something together and in mind that they could start shaping the overall journey. They also had to figure out what the branding of the application was going to be. So they had a look at the existing Irish Health Authorities promo information around COVID-19. There's some examples there on the slides, and as you can see, they have a very distinctive yellow background. This was very common in the Irish government in terms of any literature or pamphlets they sent out in relation to COVID-19. So they took that, they utilized some of the wording to keep it consistent throughout the app. They also came across the symptom checker that was already on the HSE website. So again, they were able to use that as a basis for the symptom checker that would be in the app itself. So all this was enough to give them a start into creating the first initial app screens. The initial version of the app was actually called Fight Together. That was the kind of working title when the app first started. And that was they continued on that vein to put together an end-to-end prototype that the dev team could then pick up on the Monday morning. Now the dev team also had a very aggressive challenge set by the Irish Health Authority. When they first engaged us, they asked if we could stand up a solution, now a prototype solution, not a fully working solution, but if we could have screens talking to a back end, up and running on a device by the end of a week. So 5 days of development time, essentially. And we said we could, but obviously that's a very aggressive timeline. So the things we had to put in place were obviously the app itself, the back-end infrastructure, and the back-end services, so the API layers. And then the Bluetooth piece would be taken as a separate module that we would plug later on back into the application. So we kicked off 2 teams to start working on these things. This is just an overview of the infrastructure that was put together on the back end. So we decided to use AWS as the cloud infrastructure and utilize managed services within AWS as much as possible. So as you can see here, you've got Route 53 for DNS, then calls going through into API Gateway. API Gateway was then routing those calls to 2 destinations depending on the specific API being hit. Either serving back static content from an S3 bucket or routing the calls through to the API layer that was running in Fargate. So we had a Node.js container that was deployed into Fargate, and that was acting as the dynamic API layer. And then around that, you had various Lambda functions that were utilized for different pieces of functionality, and I'll go through those in a little bit more detail. And then the backend database itself was AWS Aurora Postgres. So the kind of things we were using the Lambda functions were a lot of the batch processing that we do. So for example, when you're generating the exposure files, that's all triggered through a Lambda function, which will generate the files and place them on the S3 bucket. So the S3 bucket is used for serving back static zip files, also for serving back the static JSON configuration that the application uses. We're using Twilio for sending the SMS. So one of the flows in the application is that you will receive a one-time code if you test positive. That one-time code is sent via Twilio as an SMS message, and that's how a user is then able to enable the upload functionality within the application. So within a week, we had to put together a Node.js API. We had to stand up the infrastructure. And again, this was all using Terraform. It's infrastructure as code. We're not building this manually. And the reason for that was to ensure that we could repeat the setup of the infrastructure quite easily. And obviously, we had to build the actual front-end application itself. Now, that's just kind of a very high-level view of some of the screens that we had to put together in that first week. But by the end of day on the Wednesday, we actually had an end-to-end version of the application running on physical devices talking to a backend. So the reason that was important as well was to show the Irish Health Authority that we were capable of delivering something in the time manner that they needed. And that was critical to give them confidence that this was going to work as expected. And the other piece that we had to kick off during that first week was the challenge of Bluetooth and how do you solve that proximity detection problem using Bluetooth? So we had a look at the different options that are available in relation to Bluetooth and how we could approach this. You kind of have two choices. You can either try using beacons, or you can use the GAT, where you have a GAT server and a GAT client, effectively how peripherals normally currently connect to your phone. We initially decided to start with beacons, primarily because with a beacon, you don't have to actually create a connection between the two devices. You just have a device transmitting a beacon, and you're also looking to receive beacons. There are certainly some challenges with trying to use beacons, and specifically on iOS devices. So on Android devices, you can use Eddystone beacons, which give you quite a lot of control over what you can broadcast. iOS doesn't support those. They only have their iBeacon support. So the only variable we had in that to transmit an ID was we would be limited to 16 bits. Now 16 bits is obviously going to curtail the amount of ID information we can actually transmit. But it seemed it was probably workable for the population size in Ireland. Some of the other challenges as well around the beacons, and particularly around the iPhone, was that you had to use the location services on iPhone, that once you detect a beacon, you would then use ranging to start repeatedly receiving from that same beacon. However, this did mean that the user would have to have location enabled on their phone. Now, even though we weren't tracking location, we weren't sending to a backend server, it still creates a privacy concern from a user perspective because the app is tracking their location. So at the end of week one, we had 2 teams up and running. We had working builds. We'd gone through design iterations. We also had done some initial user testing on the design. So the HSE set up some focus groups that they were able to play back the initial envisioned designs to, just to get an initial feedback on how people were reacting to them. They also did a qualitative research report from the Department of Health, again, to see what sort of issues we were likely to encounter. This was only 1 week into the project, so there's been a huge amount of progress in a very short space of time. Things like the user feedback and the qualitative research, they were very helpful in terms of us understanding the direction we needed to take the application. So the initial feedback was that younger users were quite comfortable with the application. They got it very quickly. They understood what it did. Older users were a bit more reluctant about this type of application. I suppose some of the things we had taken for granted in terms of terminology that was being used in the app, for example, even things like Bluetooth or data protection or push notifications, was for a lot of people, they would seem like very obvious things. There was also a cohort of people that they didn't really understand what those things were or how they worked. And I guess what that highlighted to us is that we really had to focus on using very simple, plain English within the application, making sure the onboarding journeys were as straightforward as possible, and really taking into consideration those type of issues being highlighted by users. So this brought us into April, and during April there was kind of growing media attention around different countries and their efforts to build a COVID-19 contact tracing solution. The media in Ireland was aware that the Irish government had kicked off an initiative, and they were asking questions about when the app would be ready, what it would do, how it would work from a privacy perspective. And ongoing concerns along that line. In April, Australia actually launched their contact tracing application. And theirs was based on the Singapore code base. Australia and Singapore have a very close relationship, so they were able to get access to their code. They reskinned the application for Australia, and then they launched it. They had a very positive uptake in terms of number of downloads from the application, but the application itself suffered from a lot of problems. And these were the same Bluetooth problems we were encountering as we were trying to get Bluetooth working. The real crux of the Bluetooth problems really is around iOS, and that continued to cause challenges. Small bit of trivia, on the 3rd of April, we actually renamed the app from Fight Together to COVID Tracker, and that was the name then the app was actually launched under later on. So back to Bluetooth and the ongoing pain we're having with Bluetooth. So iOS was proving particularly challenging. So we did manage to get contact with Apple and get a call in place. The Irish government reached out and they got relevant people on the Apple side that understood the Bluetooth limitations and specifications on iOS very well. We explained what we were doing for them with the beacons. They recommended we switch across to using the core Bluetooth framework and switching over to using the GATT approach. Now, they also were kind of open to us and said, look, you're still going to have issues, right? It's not designed to allow ongoing two-way communication between two devices in the manner you're trying to achieve. Typically, for example, a peripheral connect to your phone, and your phone will receive information from the peripheral, but it's not working as in the phone is also trying to be sending the same information back to the peripheral. So what we were trying to set up was that the phone was both a GATT server and a GATT client. And again, you could get this working perfectly on iOS when the application was in the foreground. But as soon as you locked your phone or the application went into the background or you closed the application, it would effectively stop working, right? It would pick up some events, but not most. And this was a challenge that every country was trying to solve. So we were in collaboration with a lot of different countries that had kicked off building a digital contact tracing solution. And they were all hitting this exact same problem. And there was frequently, you'd get a message or a notification, something would come through to say such a country thinks they've solved the issue. Everybody would get very excited, and then it would turn out that that just wasn't the case. So, and there was a lot of, people reaching out to Apple saying, is there a way around this? Can you give us access to like restricted APIs and make special exceptions for these kind of apps? There must be some way to solve this particular problem. And I guess the other big issue that was getting more attention at this time as well was the whole conversation around centralized versus decentralized. So we were at that time building a centralized application. Centralized application basically means that when, for example, if I test positive and I upload my information to the server, what I'm uploading is that is coming from me, but also all the people I've had contact with. So all the people I've had that 2 meters or closer for 15 minutes or more. Now that would all sit on a centralized server. It would allow epidemiologists to understand things like the super spreaders, which, how many people on average are being infected by one positive person, and so on. And that was information that they're very interested in. It's information they collect through the manual contact tracing process. But it did raise concerns again about, it's a government launched application, and now there's going to be this data sitting on a server that allows the government to see like who's had contact with who. And again, there was very clear statements being made that this information was only going to be reused in relation to COVID-19, etc. But still, it does raise privacy concerns for people. So the alternative is a decentralized approach where the data all stays with the user. So all the data that's being collected as you come into contact with people is staying on your handset. It's not going back to a central server. And when you test positive and upload, what you're uploading are your own identifiers, not the identifiers of people you've had contact with. And then all the other applications, they're pulling down those identifiers in the background, checking to see on their local database of identifiers they've had in contact with over the last 14 days. And if they see there's a match, then they will tell the user that they've had a contact event with somebody that's tested positive for COVID-19. But the key things there from a privacy perspective are you don't know who you've had contact with. You just know you've had contact with somebody that's had COVID-19. And the person that tested positive for COVID-19 also doesn't know who they've alerted. So everybody stays anonymous. So towards the end of April, on April the 26th, Apple and Google announced that they were going to launch the exposure notification services framework. And this would basically solve the Bluetooth problem. Because they obviously control the OS on Android and iOS, they were the best place to make it work as people needed it to work. And they were solving some key issues. So one, obviously, it was going to work effectively in iOS. It would also, though, continue to work when people had actually closed the applications fully. It would continue to collect exposure notification information, after you reboot your phone, etc. And they were also going to solve one of the other big pain points around using Bluetooth and distance calibration. So Bluetooth is not specifically designed for measuring distance. You're measuring distance by relying on the signal strength degrading as you get further away from a person, which sounds like it should be pretty reasonable, but it's not always particularly accurate. And one of the challenges you have is particularly on Android, where you have lots of different device types, different manufacturers, different chipsets, different capabilities. So when you're measuring signal strength, like a signal measured from one device could end up being very different to the signal measured from a different device, even though they're both at the same distance. So Google took on the challenge of trying to calibrate that information across all devices. Again, they're best placed to do that. One of the first calls we had with Google, they kicked off the call by saying, hi, we're Google, we have 2 billion devices, how can we help? So, they have the experience, they have the reach, and obviously they have the people that can take on that type of challenge. Each individual company trying to build a contact tracing application, doing their own device calibration, is just a huge challenge. And as part of the ENS framework, it was to be a decentralized framework, right? So that was part and parcel of how it was going to work. So Ireland had a big decision to make. Would they go with the exposure notification framework, or would they continue with what we'd already built and try and get it working, but understanding that it may not be possible to get it to the point where it would be as effective as it needed to be? Now, it might seem like that's a fairly simple decision to make. However, that change in how the information the epidemiologists would get made that a less, a not so straightforward decision, because they had to trade off on having that information that the epidemiologists really wanted to getting a better technical solution. But they made a tough choice, and they made it quickly. And Ireland was one of the first countries to confirm to Apple and Google that they would go with the exposure notification framework. So that was our next challenge. We had built an app that was working. It was a centralized approach to building a contact tracing application. It was using our own Bluetooth implementation. And now we had to switch across to using the exposure notification API. The API itself was still in development. So both Apple and Google were releasing beta versions in May. We were trying to work against those beta versions. So often you would get something working, then you'd get a new beta version that would break it because they hadn't stabilized the API itself yet. So that was kind of an ongoing process. It was also raising more questions in the media because the media had known since March that the Irish government was working on an application, and you had a lot of media and likes of social media saying like, "Where's the app? What's happening? They're never going to get there. It's typical government, too slow to deliver anything." But I suppose from our perspective, it was very important that we built the right application. There was no point rushing something out that wasn't going to work properly. I mean, we'd looked at some of the feedback and reviews on the Singapore app, the Australian app, and because of that particular iOS issue, effectively, they were getting a lot of poor reviews. And in conversations with the Singapore and Australia team, they basically acknowledged that there was no information coming from iOS devices. So whilst they were getting contact notifications from Android devices, they were getting nothing out of iOS. And that's a huge chunk of your market to not have an effective solution for. In Ireland, for example, 35% of the market are on iOS devices, and then the rest spread across Android devices. So, and as I mentioned, there was attention in the media in terms of what's happened. We had to let the media know that it was now going to be June before the app would be released. But again, it gave us a lot of time. It gave us that time we needed to, one, get the ENS implementation itself, and then obviously there's going to be a lot more testing required to validate the ENS itself that was working as expected. So that's where we were when we headed into June. June was very much testing of everything, right? There was a very large effort to make sure that this was going to work as expected when launched to a national population. And we had different types of testing going on. We obviously had functional testing of the app itself. We had design testing happening. We were getting user feedback sessions. We were also looking at going through a penetration testing, again, which was quite extensive. They were testing both the application itself, the backend APIs, but they also had access into the AWS infrastructure, and we're going through that with a fine-tooth comb to make sure everything was configured against best practices. So that level of testing was critical as it progressed. I think our external test vendor clocked up something like 4,500 hours of testing. So it kind of shows you the effort that was going in to try and make sure that this app was going to work on as many devices as possible in the way it was supposed to work. And there's other things as well you have to get in place as part of getting ready to launch an application. So there was things like promo videos. We had to get all the Appstore collateral together and set up. We also initially, when the app was being conceived and launched, the plan was to launch it just in English. Because of that little bit of extra time, it was decided to also translate it into Irish to have that support in there. And we were continuing to do user feedback and on-site testing. So we set up a couple of different test scenarios. So there was 2 pilot test phases that were run in Ireland. One was a with the ERSI, which is the Economic and Social Research Institute in Ireland. For that particular trial, we actually created 8 different versions of the app. So the onboarding screens were set up in 8 different flows. And the reason for that was they were trying to determine which would be the most effective in terms of how people would work with the app and understand it. We also did a test with the police force in Ireland, the Garda Síochána, and the purpose for that at the time was they were one of the few groups that were still out and about every day. They were still interacting with each other in police stations, etc. So it was a good cohort of people to see if the actual contact detection side of things was working as expected. So the way that would work is we would simulate making, for example, one of the sergeants positive as a COVID-19 person. They would upload their keys. And then you would check and validate that officers they had been in contact with would receive an exposure notification. So there's a lot going on in the background to make sure all this was going to work as well as we could hope. And again, ongoing press in the media. It was actually in June as well that the UK decided to abandon their custom Bluetooth solution and also go with the Apple and Google contact tracing API. And there was various surveys happening in terms of what percentage of people are willing to download the app. And there were still questions being asked by the media around privacy, like how is this app going to work? Exactly what is it doing? We want to know more. So on just towards the end of June, 26th of June, we actually open sourced all the source code for the application. And the HSC, the Irish Health Authority, they also open sourced a lot of the documentation that they put in place as part of the process. So for example, they created a data protection impact assessment, which they'd sent to the Irish Data Protection Commissioner. They published the response from the Data Protection Commissioner, and a lot of additional documentation. They also published a lot of the user feedback reports that have been generated, some of the test results, and obviously the source code for the entire application. And that was both the UI code, so the app itself. It was the backend, so the Node.js code, the Lambda functions. We also open sourced all the Terraform for standing up the infrastructure. So everything that was involved in actually building the application was open sourced. Now this was the first time the Irish Health Authority, the HSC, had ever open sourced a project. So they were quite nervous at the thoughts. They were, whilst a lot of people will say transparency is a great thing, when you haven't done it before, it can be a little bit daunting. But it got a very positive press response. So a lot of the media attention about, we're concerned about this application. There was privacy groups that have been lobbying the government to know more about what was happening. When they got access to all this information, there was very positive responses from a media perspective and from the privacy groups. In fact, one of them pointed at the DPIA and the open sourcing of it and the publishing of the information as the gold standard that all other government efforts should try and adhere to. So that was the 26th of June, which was 95 days after we were first contacted by the Irish government and asked to help. So within 95 days, we had built the app twice. And got it fully ready for launch. So at this stage, it was now approved by Apple and Google in the Appstore and Play Store, and it was ready to go live. However, we had a further delay in Ireland. So at the time, Ireland was going through the formation of a new government. So there had been general elections back in February. It had taken a while for a coalition to be agreed. For the app to be launched, it needed cabinet approval. So the outgoing cabinet didn't want to make that decision on one of their last meetings, so they pushed it off to the new cabinet that was being formed. So that delayed the launch of the application by about 10 days. And just to give you a little bit of a sense of like all the different groups that have been involved in this effort, right? So it wasn't just us working with one group in the Irish government. So we had the HSC, we had the Department of Health on Garda Síochána, the Defence Forces, we had Central Statistics Office, Ordnance Survey, ISAS were the penetration vendor. They worked with EdgeScan to do all the penetration testing. Explio were the external QA vendor, so they were doing all the functional testing and also doing all the distance testing around ENS to validate that it was working as expected. We also did a lot of work with NCBI. So NCBI is the National Council for the Blind in Ireland. So again, one of the key requirements of the application was that it would be as accessible as possible to people with disabilities. So we'd added support for voiceovers, dynamic text sizes, smart invert, etc. And they were a really useful resource in helping us ensure that we'd implemented those things as expected. So we were now into July, and July was going to be launch month. So as I said, at the end of June, the app was ready. It was in the App Store. It was good to go. It sat there for 2 weeks with nothing happening until we got that government approval. And then on the I think it was either the 4th or the 5th of July, we got the cabinet approval, and the plan was to launch the application on the 7th of July. So in preparation for the launch on the 6th of July, we actually put the app live in the App Store and Play Store. And the reason for that is Apple and Google both recommend that you go live with an application about 24 hours before you sort of publicly push it, so to ensure that it appears in their search engines. Otherwise, you run the risk of people won't be able to actually find the application. So one of the strange things that happened is, I suppose, we were putting the app live. Like I said, it had been sitting there for 2 weeks, ready to go. But there's always that, that worry that something's going to go wrong when you actually go live. So within about 20 to 30 minutes of the app being live in the App Store and the Play Store, we started noticing that the app was getting traction. So within the first 2 hours, we'd already had 20,000 downloads. There was already people on Twitter tweeting about the fact that the app was now live and downloading it. The previous Minister for Health was one of those early adopters and had tweeted out that, to tell people to go and download the app. So that was quite unexpected to have that level of uptake in such a short time. And I know 20,000 doesn't seem like a lot, but we really didn't know what to expect from this application in terms of an adoption rate. By 7 a.m. the morning of the 7th, we already had 50,000 downloads. The actual public launch wasn't scheduled until 11 a.m. that day. So by 11 a.m. that day, the app had been downloaded 300,000 times, and by the end of the day, 850,000 times. So for the Irish app, it had reached 25% of the population within 36 hours of going live, and that over 1 million people had downloaded within 48 hours. I suppose, that was a phenomenal success from the Irish government perspective. I mean, they hadn't expected that level of uptake. They would have been happy on day one if they'd received 100,000 and would have thought that was very successful. So it was a phenomenal number, because they'd say other countries had also launched apps in the previous few weeks. And they had some good uptake, but none at this level. Like, this was quite exceptional. And I think a few things really helped drive that. One, there was the transparency that had happened 2 weeks in advance, in terms of making all the code available, making the documentation available, and taking away a lot of those media concerns over whether this app was the right thing for users, whether they should download it, and recommending to people that they get involved and download the application. There was a lot of social media attention on July, that day of the launch, and the following day, the COVID tracker app was trending #1 in Ireland on Twitter. And there was, in general, it was a very positive social media response. From the NearForm perspective, there was good feedback in terms of the experience within the app itself, which obviously we were very pleased about. And technically, the app, was standing up. We had no issues on the launch day in terms of the volume of people that downloaded and onboarded throughout the application. Everything was working as expected. So it was a great start, but that doesn't mean everything was perfect. These are just examples of a couple of letters that were sent in to the Irish Times, to the editor. So while some people were very happy, there were also users that the app didn't work for. So one of the limitations of the exposure notification service from Apple and Google is that it doesn't support older devices. So on iOS, for example, it's on iOS 13 and up, which means effectively iPhone 6S and higher can support it. So we had a lot of people that are still on iPhone 6s, which is still quite a popular handset. But it meant while they could download the app, because the app itself supported iOS 12 and up, the actual contact tracing piece didn't. So for them, it was a bit disappointing to be able to download the app on board, but be told they couldn't do contact tracing. They could do the other features in the app, like the symptom checker, they could see the stats on COVID-19, but obviously they wanted to do the contact tracing piece as well. So, I suppose it was great to get the app live, was it good to get it launched, was ENS solved a lot of problems. It didn't solve all problems. There were still ongoing challenges and things we need to look into and address. So I suppose in a way you might think that's the end of the journey. The app has been launched. Everything is good to go. What could possibly come next? But the HSE, as part of, during the process whilst they've been building this application, they had been very willing to collaborate and cooperate with other countries in terms of sharing information, in terms of what they were doing, how they were doing it. And they were also willing to make the source code available to other countries. And that first started with Gibraltar, actually. So Gibraltar, whilst we were building the Irish app, we also built the app for Gibraltar, and that actually went live earlier than the Irish app back in June. But as part of the overall initiative, the Irish government made a quite big decision that they would donate the entire source code to the Linux Foundation. So on the 20th of July, the Linux Foundation Public Health Initiative chose the COVID Tracker Ireland app as one of the first 2 open source apps to be brought into the project. And this is, again, very important from an open source perspective, because you now have the Linux Foundation that are backing up this particular application and encouraging others to come along and utilize this code to build their own contact tracing solutions. So in the Linux Foundation Public Health, the project went in there and it's called COVID Green. And again, all the individual pieces were pushed into COVID Green. So the Terraform for the backend infrastructure, all the backend services, all the Lambda functions, the app itself. The app itself is actually React Native, so it's a single code base for both Android and iOS. And then there is a native module that we're using for talking to the ENS service, again, and that's all sitting there in COVID Green. And COVID Green is where we continue to enhance and develop against. So NearForm is continuing to push improvements to COVID Green, but we now have other jurisdictions as well actually taking up COVID Green and utilizing it themselves. So NearForm has used COVID Green to build solutions for other countries. But it's great to see other countries taking that same code base, using it for their means, and then actually feeding back into COVID Green as they either make improvements or identify particular things that we've done better, etc. So one of the key ones that NearForm rolled out utilizing COVID Green was the Northern Ireland application. So this went live at the end of July, and one of the key requirements for that application was that they wanted interoperability between Northern Ireland and the South. So there's a land border between the two. You've got approximately 30,000 people that cross that land border on a daily basis. So for them, it was key that any application they launch would need to be able to communicate seamlessly to the app that was already launched in the Republic of Ireland. So to achieve that, we did build a specific app for Northern Ireland. You can see some of the imagery there. It's very different to the Irish application. It also had different functionality. So Northern Ireland made the choice that they would only focus on contact tracing. So they have no symptom checker. They don't show you stats around COVID-19 in Northern Ireland. They took the approach that the app should be as simple as possible. The user just needs to onboard and then they don't need to do anything else. So, but as I said, the key thing was this needed to be interoperable with the solution in the Republic of Ireland. Now, the good thing about using exposure notification service is it means that the keys that are being exchanged between phones are not tied to a specific app or a specific app implementation. That's happening at the OS level. So you have interoperability in terms of the data. So your challenge then is to figure out how to get the data between the two environments, because the Irish app is talking to its own backend sitting in its own AWS account, which was sitting in EU West 1. The Northern Ireland app, it also has its own AWS account sitting in EU West 2, and there's no connection between the two accounts. So to solve that problem, we set up a federated server. Now, this was something that was being talked about across Europe, and there was an intention that there was at the time an intention to stand up a European federated server. But Ireland and Northern Ireland were the first two countries in the world to actually go live with a federated server. And the flow for that is very simple. You can see it in the diagram there. So this is the same, on the left and right, you have the same diagram that I showed earlier from an infrastructure perspective. And what you have now is a couple of additional lambdas on each side. So you have a lambda for sending keys to the interop service, and you have a lambda for retrieving keys from the interop service. So each backend is sending any keys that are uploaded into it. They also send it to the federated server, and they pull down any keys from the federated server that have come from the other region and then store them in their own database. And then once they're back into each local account, then they're just served out in export files the same as keys had been previously when users uploaded. So it's actually quite a simple way to federate keys across the two environments without requiring a direct connection between the two environments. And that was important as well from a security perspective, because you kind of want that, the ability to get effectively circuit break if something does go wrong, right? You don't want a direct connection between the two environments. So from a security perspective, it's much better to go through that buffer zone in the middle and take care of things there if needed. So as I said, Northern Ireland and the Republic of Ireland were the first two countries in the world to launch a contact trace COVID-19 interop service. And again, that worked very effectively. It has stood up, it's running as expected. Later on, NearForm also integrated the Republic of Ireland with the European Federated Gateway Server that was stood up in October. So this was initially, first three countries to interop across Europe were Germany, Ireland, and Italy. And since then, some additional countries have joined that European Federated Gateway Server. NearForm also stood up a federated server in Scotland, and this was to be used in the common travel area. So there's now a federated server running that is basically syncing keys between Scotland, Northern Ireland, Jersey, England and Wales, and Gibraltar. So again, these are all sort of key pieces in helping, again, do that contact tracing across borders. So I suppose, where did we go at that stage? So at that point, we'd launched Northern Ireland, we'd launched Gibraltar, we'd launched the Republic of Ireland. We then went on to build applications for Scotland. We also built an application for Jersey. And then we built applications for US states. So we built the application for Pennsylvania, New York, New Jersey, and Delaware. So I think by mid-October, all those solutions were live. And it might sound like it's a fairly simple task to, like, once you've built an application once, to then roll it out multiple times. But that in itself is quite challenging. Like, when we kicked off building this application for Ireland, what we were building was a bespoke solution for the Irish government. Then, as we started getting interest and traction from other countries that were also interested in having the same solution, we had to effectively productize that solution that we've been building, because we didn't want to duplicate the code and, you know, copy and paste and then just roll it out for each different environment and have very bespoke changes. We had to think about more from a product perspective in terms of how could we build a product that could be flexible enough to cater for the different requirements that were coming from different countries and different US states. So a good example of that, for example, is the integration into the manual contact tracing system. So the back ends of all the digital solutions also have a connection to the manual contact tracing system, because the manual contact tracing system is typically the piece that actually initiates everything. And what I mean by that, for example, if you test positive for COVID-19, you obviously physically go and have a test somewhere. Your test results will be sent to the manual contact tracing system. And typically the way it works is they'll contact you by a phone call and tell you you've tested positive. And then as part of that process, they'll ask you if you have the app. And if you do have the app, they will send you that SMS code to enable the upload feature. So you have to integrate, the manual contact tracing system has to be able to call into our backend to trigger that SMS process. But also, one of the features we have in place in some countries, so for example, in the Republic of Ireland and Jersey, when you're setting up the app, you can put your own phone number into the app. Now, the phone number is held on your phone only until you get a contact notification. So you have an exposure alert event. And at that point, we send the phone number from the app through our backend service and back into the contact tracing system. And effectively, in there, it gets queued up for a callback from a manual contact tracer. And the reason for that, again, is a lot of people, certainly initially, you know, they found it very daunting to receive an exposure alert. So having a human they could talk to really helps them kind of understand what it is they need to do, etc. So you had all these challenges in terms of making the product flexible enough to meet these different needs. And some of that flexibility was generally handled through creating regional or country-specific or US state-specific Lambda functions. So the core of the backend would remain the same, and then you would have bespoke Lambda functions that would do those integration pieces. In terms of the apps themselves, they are separate code bases, the actual front-end app, the UI piece. And the reason for that is they're all completely bespoke. So you can see some of the kind of splash screens in the screen share at the moment there. But if you go through all the different applications, they're all completely different. And whilst they have similar functionality, I mean, obviously they all do digital contact tracing using the exposure notification service. You know, some of them have the symptom checker, some don't. Some have stats around COVID-19 in their particular region, some don't, and obviously they show different stats. So since initial launch, we've gone on to continually enhance the applications. We've added features like the ability to pause contact tracing, so that was particularly useful for people that worked in an environment that relied heavily on PPE, so for example, frontline health workers. It didn't make sense for them to be getting alerts from the app because they're protected by PPE. So we provided simple options in the app to do, for example, an 8-hour pause of the contact tracing feature. We also launched the app in multiple languages. So as I mentioned, in Ireland, we had covered Irish and English in the initial launch, but for example, in New York, they launched the application supporting, I think it was 7 different languages. We've added 2 since. We've also added right to left language support, so we can support Arabic, etc. And we're continuing to add features to the apps across the different regions, depending on what their specific needs are. So, you know, again, we've kind of covered interoperability, we've covered language support, and I guess one thing to mention as well is in the US, interoperability is handled a little bit differently. So Apple, Google, and Microsoft got together in the US and decided they'd stand up a single backend key server for all US states to connect to. So instead of every state having to figure out how they share keys with every other state, all the states would connect to the same backend server effectively. And that solved their interoperability issue. And again, as part of rolling out the solution into the states, we had to make sure we could also connect to that same server, which again was some changes because our original application had been built to talk to the NearForm backend server. We continue to make improvements around accessibility. And we were also collecting metrics in the application so that we could report back and the countries and states could understand if the apps were actually working and being effective. So the type of metrics we were capturing will be things like, for example, uploads, number of uploads, but also the number of contact alerts that have been generated by the applications. And other high-level metrics like that. And they're collected in a very anonymized manner. They can in no way identify a person, but it does allow the government and state to have an understanding of if the app is actually working as expected. And that's it. Thank you very much. It's been a pleasure to present this, and I'm happy to take any questions if anybody has any.
Okay, thank you very much, Colm. I think there is, at the moment, I've only got one question about the federated approach, which I think actually you've answered anyway, because it says, you know, obviously it's easy to add more countries to a federated set. But I guess the differences in the protocols between different countries would mean that you wouldn't necessarily want to do that unless it was under the sort of aegis of the EU or something like that.
Yeah, I mean, like if you take for example, the European Federated Gateway Server, so that's open and available to anybody that's using the exposure notification service from Apple and Google, because again, the keys are all of the same format and using the same protocol. Countries that have gone with their own implementation, you know, at the moment there is no real easy way to do interoperability with those because of effectively they're two completely different data sets.
So, for example, the states in USA, you said they're all collaborating with a central server.
Yep. So they're all sharing a single backend key server, but it's still using the exposure notification. So that again, that backend key server is for states that are utilizing the Apple and Google exposure notification server. So you could quite easily set up interoperability between the US and the European Federated Gateway Server. One of the challenges with the whole interoperability piece is the volume of keys as it gets larger. Obviously, it's, you know, you're now talking about larger downloads to phones, so the contact tracing applications are using more of your bandwidth on a daily basis. And the phones themselves will take more time to process large volume of keys. Now, testing has been done, like, you know, testing batches, for example, of a download that contains 9 million keys. But on lower spec devices, you know, that was starting to become a problem on those particular devices.
Yes, obviously with backward compatibility is the other issue, of course.
Yeah.
Okay, well, there don't appear to be any other questions. So obviously you've done an extremely good job. So I'd just like to thank you on behalf of BCS